Hi friends, welcome to our channel. Today we will discuss central concepts of automata theory. What do you mean by the central concepts? Central concept means simply the basic terms that are going to use in the automata theory. So the first and the foremost important basic term is alphabet. What do you mean by alphabet? An alphabet is simply a finite, non-empty set of symbols. A finite non-empty set of symbols is called an alphabet. Generally, the alphabet is represented by using the notation sigma. For example, sigma is equal to 0, 1. Here, these 0, 1 are alphabets. Suppose sigma is equal to a, b, c. A, b, c are called alphabets. That is the symbols that are going to use in a string. Now, the second term is a string. These are the terms that we are going to use in this automata theory. The second term is string. What is a string? String is simply a sequence of symbols. A sequence of symbols from the alphabet. You have to remember the point. That is, a string is formed by using the symbols from the alphabet. Generally, a string can be represented by using the letter W. For example, sigma is equal to 0, 1. This is an alphabet. Now, 0, it is a string. Suppose 1, it is a string. 0, 1, it is a string. 0, 0, 1, 1, 0, 0, 0, 1, 1, 0, any combination. That is a sequence of alphabets form a string. Now, in this string, we have a special case also that is called empty string. What is the difference? A string is, it forms a sequence, but empty string means simply a string without any alphabet. A string without any alphabet or without any symbol. Generally, empty strings are represented by using epsilon. This is the representation by using epsilon. Okay. Now, one more important term is coming to strings. In the strings, generally, we are performing different operations. So we can calculate the length of a string, prefix of a string, suffix of a string, and concatenation of a string. For example, we will discuss each and every one. And if W is the string, and this modulus W, this represents the length of the string. So what the length specify? The length specify the number of alphabets or the number of symbols present in the string. For example, if W is equal to some 1101, 1. What is mod W? The length of the string 2, 3, 4, 5. The length of the string is 5. That is the length of a string. Now, what is the second operation? Prefix. Prefix of a string means simply any number of leading symbols. Any number of leading symbols of a string. That is the prefix of a string. Simply, what is suffix? Any number of trailing symbols is called suffix of a string. Okay. So up to now we discussed three terms. One is the prefix and another one is suffix along with the length of a string. For example, consider a string W is equal to ABC. What is the prefix of a string? Any number of leading symbols, that is epsilon, A, AB, ABC, all these are called prefixes of a string. Similarly, suffix. What are the suffixes of a string? Epsilon, prefix means from the starting, suffix means from the ending. So, C, BC, ABC. These are the suffix of a string. Okay. Now we have one more term. That term is substring. What do you mean by substring? So substring means simply any string from the main string, any string from the main string except itself. For example, ABC is the original string, AB is a substring, BC is a substring. Okay, these two are called substrings. Or along with epsilon is a substring, A is a substring, B is a substring, C is a substring, AB, BC, all these, and ABC, this is also a substring. Now, one more operation we are performing is concatenation. What do you mean by concatenation? Combining more than one string into a single string. For example, W1 is a string which contains ABC. W2 is a string which contains XYZ. The concatenation is represented W1, W2 is equal to simply ABC, XYZ, or W2, W1 is equal to XYZ, ABC. So combining of two strings is called concatenation. Okay. Now, so two terms are completed. Two basic points. What are the two basic points? What is an alphabet? What is a string? What are the operations that are performed on the strings? Okay. Now we are moving into the third important term, that is a language. That is language. This is also very, very important notation. What do you mean by language? Simply a set of strings, all are from, we are forming, that is we are creating a set of strings, all are from sigma star. Okay, I will explain sigma star right first. Now what do you mean by sigma star? Here the sigma is an input alphabet. Sigma is an input alphabet. Assume sigma is equal to 0 comma 1. That is, we have two input symbols or two alphabets, 0 comma 1. Sigma star means 0 or more occurrences. Sigma star means 0 or more occurrences of any symbol. So for example, for this 0 comma 1, what is sigma star? 0 occurrence means epsilon, 0 1 0 0 1 1 1 0 0 1 0 0 1, and so on, and so on. You got it? So sigma star means 0 or any occurrences of the string is called sigma star. Then what is a language? Language means simply a set of strings, all are from sigma star. But here we have to add one more additional point, and it forms a particular alphabet. It forms a particular notation, or a particular, that is all the sigma terms are from a particular alphabet. That means if sigma is an alphabet, then the language L subset are equal to sigma star. You have to remember this point. If sigma is an alphabet, then L is a language such that L is subset or equal to sigma star. Okay. Now I will explain one example, then it is very easy. Assume L is equal to epsilon 0 1 0 0 1 1 triple 0 triple 1, and for example one more string like this. This is sigma star. Sigma contains 0 comma 1. From the sigma star, we are forming a set of strings, not all the strings. Remember, sigma star contains many combinations, but L is a language which contains only a set of strings such that it has to satisfy some property. What is the property? Here L is the language with equal number of A's, equal number of zeros, followed by equal number of ones. You got the point? That is, what is a language? The language is formed from the set of strings with some specific property. Here, for this example, this is the property. This is the property. Okay. Okay, you got sigma star, and this is called clean closure. And we have one more term also, that is called sigma plus. That is called sigma plus. The main difference between sigma star and sigma plus is sigma star, zero or more occurrences of a string. Sigma plus is one or more occurrences. That is, what is 0, 1, 0, 1, any combination. Minimum, at least one string is present. At least one string is present. Okay. This is called language. Up to now, we have discussed what is an alphabet. Okay. How to form a string from the alphabet. How do we form a languages from the given string? Now we will move to some more basic terminology. Now we know sigma star, and we have one more notation, phi. What is a phi? Here in terms of languages, phi is an empty language. Phi is called an empty language. Empty language means simply it is a language over any alphabet. Simply it is a language over any alphabet. That is, whatever the language you are given, that is all default. That is also an empty language. Now, for example, this one, what is the meaning of this one? Here, if you are writing within flower brackets, this becomes a language. Remember the point? If you are writing within flower brackets, it becomes a language. Now the language contains epsilon. What is the meaning of this one? This is a language contains only empty string. You got the difference? Observe the difference. Phi is an empty language. Empty language means even no string is present. Here, this is a language. The language contains one string, but the string is an empty string. So that means here the value of phi is always not equal to epsilon. You got it? Why? Phi is an empty language. That means it has no strings. It is a language, it have an empty string. You have to observe the difference between phi and epsilon. Okay. Now, based on this, what is the first property? Just now we discussed. L is a language. It is always subset or equal to sigma star. That is, L is the language over sigma. Now, a language can be empty when a language, these are some of the property, a language can be empty. That means, what is the meaning of this one? L is equal to 5. L is equal to 5. And the third property, what is the third property? This one. Okay. Empty languages not equal to epsilon also. Empty languages not equal to epsilon. That is, L is not equal to epsilon. Assume if your L is an empty language, it is not equal to epsilon. Okay, this is the language. Now, on these languages, so on the strings, we are performing some operations. What we discussed on the string, how do we calculate the length of a string, prefix of a string, suffix of a string, substring, and concatenation. Similarly, on the languages also, we are performing some operations. What are the general operations we are performing? Union, concatenation, closure. These are the regular operations that are performed in the languages. So the first one is union operation. Think everyone know the meaning of union operation. How many languages you require? Union means you have to combine the two languages. Assume two languages L1 comma L2. Two languages L1 comma L2. The union between two languages is represented as L1 union L2, or Another notation is L1 plus L2. You can use any notation, either L1 union L2 or L1 plus L2. Okay, now what is the meaning this one? The union of two languages. It is a language, L1 union L2 language, that contains all the strings. This is the very important. Union contains all the strings from both L1 and L2. Both L1 and L2. For example, consider a string L1 is equal to some 0, 1, 0, 1, 1, 0. L2 is equal to some 0, 1, 0, 1, 1. Now, what is L1 union L2? Simply, it is a combination of all the strings. If it is a combination of all the strings, means 0, 1, 0, 1, 1, 0, 1, 1. Suppose if they are duplicated, simply remove the duplication. That is, only one time is present. The string is present only one time. Now, after completion of union, what is the second one? Concatenation. The second operation is concatenation. Simply, concatenation is L1 and L2 are the two languages. The concatenation between the two languages is represented as L1 dot L2, or simply we can write L1 L2 also. You can use the dot operation or not at all. It is not at all required. L1 L2. This is concatenation. How the language is formed? L1 comma L2. Sorry, before that one I will explain for union. L1 union L2 for notations. It forms a string W. That is, the answer contains a string W such that W belongs to L1 or W belongs to L2. W belongs to L1 or W belongs to L2. Similarly, L1 comma L2, it also forms a string W. Suppose this is the concatenation. Assume we have used some notations UV such that U belongs to L1 and V belongs to L2. Okay. For example, L1 contains 0, 0, 1, 1. L2 contains any other string. For example, 0, comma 1. 0, comma 1. What is the concatenation between L1 and L2? So simply this is merged with these two. That is 0, 0, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1. You got it? First these two zeros, double zero is combined with 0 and then with 1. Now 1, 1 is combined with 0 and then with 1. This is the concatenation. You got it? Now the third one is, observe, L1 L2 is not equal to L2 L1. That is 0, 0, 0, 0, 1, 1, 1, 0, 0, 1, 1. Observe, the strings are different. The concatenation of the two strings is not commutative. Commutative means L1 L2 is not equal to L2 L1. Now the final operation we are going to discuss is closure property or closure operation. In this, we required only one languages, and in this closure also we have two things. One is star closure, second one is positive closure. Another name for star closure is clean closure. Star closure is clean closure. We already discussed. For example, this is a representation for star. This is representation plus plus. Assume sigma star. This is called clean closure or star closure. What the answer contains? Simply it consists of all the words. It consists of all the words that contains zero or more occurrences. Zero or more occurrences of the word Sigma plus, this is called positive closure. It contains one or more occurrences. Okay, so consider an example. Sigma is equal to 0, 1. What is sigma star? Epsilon 0, 1, 0, 1, 1, 0, and any combination. What is sigma plus? Sigma plus is equal to 0, 1, 0, 1, and so on, except an empty string. Except an empty string. That means positive closure at least contains a string. At least contains one string. We can represent sigma plus is equal to sigma star minus epsilon, that is from the entire sigma star. If you remove epsilon, that forms the sigma star. Okay, these are the some notations that we are going to discuss in the next chapters. Okay, thank you.